Lesson 9.10, Applications of Surface Area. This is your practice packet starting on page 15. A circular fence that is 2 feet high is to be built around the outside of a carousel. The distance from the center of the carousel to the edge of the fence will be 25 feet. So from the center out to that edge, that's going to be our radius of 25 feet then. What is the area of fencing material that is needed to make the fence around the carousel? So this would be surface area, which is PW plus 2B. The difference is this is kind of one of those lateral surface area examples because we're not actually going to be putting fence on the top of the circles. We're just going to be going around that outside. So for us, our perimeter times our W. So perimeter of a circle is going to be circumference, which is 2 pi r. So in this case, I'm doing 2 times pi times 25. So that's going to be a total perimeter of 157. The W value is going to be actually that height of the fence, which it says is a 2 foot high fence. So perimeter is going to be 157 times W value is 2. And that gives me a surface area of 314 square feet then. In number 2, Marcus wants to decorate his box that's in the shape of a cube. He decides to cover the entire box with red colored paper except the circle with his name on it. The box is shown below. Round it to the nearest square centimeter how much red paper is needed to cover his box. So if we're going to go ahead and figure out this whole entire box, it is a cube. So each of these sides is actually a square, and it's 5 by 5 centimeters. So each side is 25 square centimeters. There are 6 sides on a cube. And at 25 square centimeters each, 6 times 25 gives you a total of 150 square centimeters. Marcus is not going to be covered in this circle. Since the 5 would go all the way across the side, that diameter is 5. So your radius here is 2.5. We need to take away the area of that circle. That area of a circle is pi r squared. So we're going to do 3.14 times 2.5 squared. And that answer gives us 19.625. So if we take the whole entire box, which is 150, and we take away that 19.625, we get 130.375, and it says just rounded to the nearest square centimeter. Looking at my answer choices here, it looks like 130 is going to be my best and closest answer. For question number 3, Shannon has several cubes again. So we're talking about those 6 sides that are all made up of squares. Each cube is 3 feet high. So if we have 3 feet high cubes, so same thing, 3 feet, 3 feet. So each side is going to be an area of 9. So 9 times 6 sides gives me 54 square feet for each cube. Shannon covers all but 1 with foil. So we actually don't need 6 sides. We only need 5 of the sides covered. So 9 times 5 would give me 45 square feet. She uses a total of 360 square feet of foil to cover the faces. So if we take 360 for all of them, divided by 45 per, 360 divided by 45 is going to give me 8 cubes for her. In number 4, find the surface area of the label. So this is that lateral surface area again, which is just the PW part. Remember, the 2 base gets cut off because we don't actually put the label there. The radius is 3.1 and a height of 9.2. So this 9.2 is our W value, and our radius is 3.1. So when we go to find our perimeter, that's going to be 2 pi r for a circle, which is what our base is. So we're doing 2 times pi times 3.1. And that will give us a perimeter then. It says round to the nearest tenth, so I'm going to do 19.5 for my perimeter. And my lateral surface area then is 19.5 times 9.2, which would give me a lateral surface area of 179.4 square inches. So that's example number 3 and 4, and it looks like that is it for lesson 610 practice packet.